Good morning, afternoon, or evening, wherever you are. I'm Livian Dran, and I am one of the participants under Dr. Lau's Science in the Age of AI, or sorry, Science Communication in the Age of AI project. For my specific presentation, I decided to examine different just citizen science apps and see how those can be used in science communication and entomology. And just a quick disclaimer, there are going to be some pictures of insects in this presentation, and I know some people are afraid of insects, so if you would prefer just to not watch this presentation, that's completely understandable. Put your well-being first. Just to give a background on insects, they're animals that have an exoskeleton made of chitin, three body segments, and six legs. And what's particularly notable about this group is they are the most taxonomically diverse group on Earth. To the point they comprise over half the named species on Earth. And actually, around it's estimated that around 80% of all insect species are still undescribed. And what's important about these guys is they fulfill numerous roles. They're important pollinators, decomposers. They're often prey items for larger species. In the more negative On the more negative side of things, they are sometimes pests or vectors of diseases to humans. Before I start going into the details of how the AI works, let me clarify some terms. Machine learning, it's a form of AI that essentially learns from data. Deep learning is essentially a more advanced subset of machine learning, in that it can potentially learn without its learning having to be supervised. And then in a subset of a subset, we have convolutional neural networks. Those are a type of deep learning network that's particularly well suited to just learning from and categorizing different images. So, uh, so for the AI apps, typically they use two different methods to learn how to distinguish the different species. One method is computer vision, and the state of the art for that involves just taking CNNs and just training them on large data sets just of labeled images. And what this does is over time, the AI will learn to be able to distinguish just different types of species. And with the citizen science apps, for example, iNaturalist, the way they're actually able to see the images is they use something called computer vision. And it helps them to be able to just view an image and just categorize it. And that helps them identify insects down to a species level. And another less common method is just using AI to analyze bioacoustics. And there's different models that are used to just analyze bioacoustics. Could be an ML model, could be a DL model, could be a CNN of some sort. But what they basically do is they compare intentionally produced sounds. For example, think like a cricket chirping. I think they chirp. I can't remember off the top of my head. Just byproducts of flight. So, for example, when a bee's flying and then indirectly produce sound. So, just think an insect moving through the grass or something like that. and they compare these sounds against labeled acoustic data sets. And much in the same way, AI can learn with computer vision. This also teaches the AI models over time how to just distinguish different types of species by sound. One pretty common, bleh, one pretty prominent use of AI is to identify different agricultural pests. CNNs, they're not always 100% accurate, but they are often the quickest way to be able to sufficiently identify just an agricultural pest. And what these advances in AI have done is they've enabled farmers and other agricultural stakeholders to be able to just easily and quickly monitor these pests. And just this is this to the right here. This is one of the pests in question. This is actually a picture I took myself, and I actually identified the moth through iNaturalist. This is a diamondback moth, and what's significant about this particular species here is that it's actually the most expensive agricultural pest. It costs the agriculture industry 4.6 billion annually. So, what's great about these citizen science apps is they're able to they render entomology and similar sciences more accessible to the public. So by making something more accessible, you're able to increase public understanding of that topic. The citizen science apps indirectly serve as vehicles for science education and communication. And there have been some very neat discoveries made on these apps. Just from my research, there were two different types of insects I found that were considered lost. They hadn't been seen for nearly 50 years. And then someone incidentally posted a picture of them on iNaturalist, and hey, turns out they're not extinct. And occasionally you will also have someone post a species that turns out to be completely unknown to science. So there have been numerous cases where just new species have been announced in part because of citizen science contributions. And there are a lot of different apps that are used in entomology. A lot of the time, you're going to get like apps specific to a specific insect taxon. So, for example, eButterfly is obviously used for butterflies. And then there are some more generalized ones, like iNaturalist is the big one. And then there's another app associated with iNaturalist called Seek, and then there's, I think that's pronounced OBS Identify, and then Project Noah as well. So, one example you see of AI actually being used for positive advocacy is National Moth Week. Now, National Moth Week, it's an annual citizen science initiative that takes place every last week of July. And what happens during this week is participants are invited to just basic document moth sightings all over the world. And with the help of AI, they're often able to get it down to a species level. And a lot of the time, also, you're encouraged to just create, register, and host your own events during this week. And I think what's so crucial about this is ignoring my own personal bias for moths. Moths are, they often have a reputation as just being the uglier cousins of butterflies and just being pests in general, when in reality they're a lot more diverse than that. Like, for example, they are perhaps the most significant nighttime pollinators we have. And that can contribute to a lot of things like just agriculture, like plant biodiversity in general, things like that. So, as with any platform, there are going to be pros and cons. The positives are, as I previously mentioned, the just the citizen science platforms, they serve as an amazing introductory tool to entomology. Actually, the reason I got into entomology in the first place is just because I kind of got more exposed to the field just by cataloging observations in iNaturalist. I don't actually have any formal background in entomology, so yeah. And what all these sightings do, because you can get millions upon millions of different observations. And the great thing about this is entomologists can take the data from these sightings, and among other things, they can just use them to monitor like the ranges of a population. It's pretty common for iNaturalists to cause to reveal that a species range is actually further than was traditionally thought by entomologists, and it also allows them to analyze movement patterns. And of course, AI in itself is a pretty major double sword. One of the biggest weaknesses of it is with how many different insect species there are, it's sometimes very difficult to get them down to a species level. The like for example on iNaturalist, the AI suggestions aren't always going to be super helpful or 100% accurate. And this is especially going to be the case when you encounter a cryptic species or species that are visually identical, because a lot of the time in that case, you have to combine like the image data with molecular data in order to be able to truly identify the species. And the use of AI in this manner does also come with a lot of ethical concerns, because it's people who aren't scientists that are submitting the just the observations. There's a lot of concern over how accurate is this data, because while one person might be able to readily identify an insect species, a lot of people will just go with what's suggested to them, even if it's completely wrong. And there's also intellectual property concerns, just because you are taking someone's own observations and using them for your own research. And that's kind of a slight gray area when it comes to intellectual property rights. And that can also come with conflicts of interest. And there is sometimes a concern that the observations of citizen scientists are exploited because their observations are being taken and they may not be getting credit for those observations. So, just the key takeaways for this presentation. So, insects are an incredibly important taxon. They fulfill numerous niches that is important to both ecosystems as well as to humans. So, citizen scientists typically use apps trained on machine learning models, deep learning models, or convolutional neural networks to be able to identify insect species. And like I literally just mentioned, the involvement of AI-assisted citizen science in entomology has its pros and cons. It increases the awareness and accessibility of entomology and provides incredibly crucial data. I cannot understate that. But this is somewhat undermined by the fact the IDs aren't always accurate, so you can't take the data at face value. And the use of AI comes with the ethical concerns I previously mentioned. So, yeah, just for acknowledgements, I'd like to thank BMSIS just for giving me the opportunity to participate in this wonderful program, and Dr. Lau just for being an incredible advisor just throughout this entire project. And here are the many, many references I used. Is that? Oh, okay. I believe that's the end of it. So, are there any questions?
Awesome. Great job, Liv. Sanjoya, you have your hand up? I think we have time for one question.
Mhm,
If nobody else has a question, I'll ask one.
mhm,
Going once. Livian, thank you for
mhm,
presentation. I agree, insects are fascinating. So at least in iNaturalist, the machine learning detection is not enough for the data or the picture to become research grade, right? It needs to be recognized by two other users of iNaturalist who look at your picture, identify the species,
mhm.
and confirm it before it becomes research grade. Do you
Oh,
think
yes.
that this kind of model of like verification by a human eye of machine learning identification is enough?
So, to be honest, in my experience, a lot of the time it isn't fully enough just because, a lot of the time, like, basically anyone can confirm that an observation is research grade on iNaturalist. It's not like vetted by like experts or anything like that. So it's pretty common for someone to just suggest the top suggested species to them. And then someone else comes along and just thinks, hey, that looks similar enough. So they also agree that's the same species. And so then it becomes research grade. And the problem that's so the problem with insect species in particular is there's so many of them. And a lot of the time, in my experience, just on iNaturalist, it's pretty common to get the genus right, but sometimes the exact species may be wrong. But because no other ones of that genus are suggested, people go with the top recommendation.